Hi everyone, this is about the third part of the Form 5 Chapter 2 Maths Differentiation. Okay, so now about what we will learn for differentiation. First, we will know what is the first derivative, the second derivative, and what they use for. From here now, it's very important because before this, all that you learn just now means just a basic for you, and you not oftenly came out in the exam paper, for sure in trial or SPM, but behind here is most important because they will came out frequently. It will came out frequently, so need to be alert for that. So in this chapter, differentiation can use for to find the equation of tangent and equation of normal. Given that this is a curve here, now when you want to find a gradient of the curve, you need to draw a line here. You draw a line there, and that line you call as a tangent. I think you learned this one in your Form 3 chapter 6. Tangent means the line that touches the circle one time at one point only, intersect one point only, and cannot be intersect in another point. But now if I say that this is a tangent, so when I rotate the line 90 degrees, so I can say that that is a normal line. In Form 4 physics, you know about this one. It is called normal line. And normal line, this one, you can say that both lines intersect together will form a 90 degree. It's perpendicular. So if the line is perpendicular, so it means the gradient of the tangent and times with the gradient of the normal is equal to -1. The proving step you show later in the video. And this equation, I think you know before in Form 4 chapter 7, but now this equation is used for to find the equation of the tangent or the normal. Usually is finding the equation of the normal. This equation is came from gradient formula. M equals to y2 minus y1 over x2 minus x1. This is how they call it going on. The x will go up here, and here we could call 1 point only. So we can say that it's us use 1 point, and another point put x and y, just enough. It is for curve, for simple curve. But how about the curve like this? Very difficult. Now here, actually this is an image for you. When we want to find something in the graph, either you find gradient, because gradient is dy over dx. So we see here, all the points that are pointed here, we call this as turning point. Also you can say that that is a nature point. And the curve is very beautiful, but I'm sorry to say that if you want to find a point, find the gradient of the graph, so what you do, you will extend line here. So when you extend a line here to find the gradient, if the gradient is moves up like this, you can say that the dy dx is positive. Also dy dx is larger than 0, positive. But if I draw the line, I extend the line, it's going down, you can say that dy dx is smaller than 0. But if I draw the line here, how will going on? This one, you can say that dy dx equals to 0, since all the gradient of the tangent actually is the same thing, because when you do the y to differentiate the differentiation for the y, you automatically will say that this all curve here, okay, they are using the same equation gradient, but okay, with different answer. Okay. Now, to determine the coordinates of the turning point, first you need to find dy dx. Okay, differentiate the y. Later on, using dy dx over dy dx equal to 0 to find the turning points. Okay, dy dx you have, and dy dx equal to 0, you need to find what? Find x. Basically, x will have two answers, either 1 or 2. Basically, two numbers. And two numbers, when you find x already, using y to find y. Okay, the equation y to find y. Okay, sub the x inside the y, you get the answer, then you can say that is the turning point. Okay, you have 2 points, okay, the 2 coordinates, and that is called turning point. But you do know what they are. What they are, either is maximum or minimum. Okay, if the picture given, image given here, it's very easy. Okay, all the point that just stays here we call as stationary point. But if the graph is moving like this, like go up, okay, we call that as a maximum point. Okay, if it goes down like this, the curve is like this, we call it as a minimum point. And to determine the maximum and minimum point, either we use second derivative method or tabulation and sketching curve method. I prefer using this method because it was easy compared with this method. Later I will tell you. Okay, second derivative method. Okay, when you're done for the second differentiation, okay, you have x, so you have the x, so what you do, okay, you sub the x inside the d2y over dx square. When your answer going to n, okay, you detect if the second derivative, the answer is less than 0, that we call that turning point is a maximum point. Okay, vice versa. If I say that d squared y over dx squared is larger than 0, the answer of y is larger than 0, that is a minimum point. Otherwise, d squared y over dx squared equals to 0 means that is an inflection point. Okay, inflection points you occur, they have 3 points or more points. The curve is very curved. It is for the first method. Second derivative method. The second method is tabulation and sketching curve method. Okay, do the same step before the dy over dx. You already know all the step before, you already know about it. But when you want to move to find either these two turning points are maximum or minimum, you're using this method. Okay, the first x, this is your first x. What you do, you put the number that is closer to the number you find for the x. Okay, the closer, larger or lesser, and then you find dy dx. If you already find dy dx, check their value. If positive value, goes up. If negative value, goes down. If 0, just put like this and you sketch a graph like this. Now this is also same thing. Okay, find the closest number. Okay, and then larger and then lesser, and then just do the same step like this, and you get this one. This one we call as a maximum point. This one we call as a minimum point. It is how the second method going on, but this method I not suggest you to do because it's quite long step and you need to be careful about the answer. So I prefer you to do in the first step, the first method. This method you use when it's really no step can use, only this method can use, then use for it. Okay. And this note behind got some questions is like this one. Okay, you can just do whatever you want. Okay. The second about the application for differentiation is rate of change. Okay, it's actually is the thing that you learn in Form 4 Chapter 10 and Maths. Okay, one of the chapter that is quite easy for you. Okay, now the first thing is to determine the rate of change. You need to find the rate of change. Okay, and then you write the rate of change by using change rule. Okay, because you have the same, because you see, if you have the same variable, just put and then fill the blanks with the written quantity and you find what you want to find for. Okay, let's see at one example. Okay. Okay, now it's given that y equals to 3x squared minus 4, x equal to 1 over 2. Okay, find the rate of change of y, means delta y over delta t, because time. If the rate of change of x is 2 units per second, 2 units per second means delta x over delta t. What is going on from here? Okay, what is going on from here? Okay, why I said that delta y delta x what is going on here? Okay, we need the answer here like this. dy dx, not delta y dx. I'm confused about that. Okay, first you do the differentiation dy over dx. Okay, given what? Given x already, sub it and you find the answer dy dx. Now what you want to find? dy over dt, because rate of change of y means, okay, if behind got said that is the second, got cm, all that. Okay, if cm is length, either is a area, area is nothing, length. Okay, if cm squared is area, okay, like this, if I said that is 2 units per second, so I say is dt. Okay, because I using the same number for the time, so I can say that is the dt. dt is a constant, the same thing, but now dy over dt, so I make it kembangkan, because dx here to here is same, so I make this one dx. So dy over dt, 3 times 2 equals to 6. Because I got a number here, and then dx over dt, I already know in before. Okay, in before. Okay. It is how rate of changes going on. But how? Another thing going on. This is called small changes. This one is the last part. Okay, last part of the chapter, the whole chapter. Small changes. Just now before we learned that about the limits and relation. Okay, the function has a limit when you're finding the answer. If you're finding the limit, okay, you already go for the limit, so you become undefined. Small changes means, okay, the things that suddenly changes, has a small changes. You didn't see anything change or not, but it changes, bertukar tapi dia berdiam-diam. They are silently changed. They didn't tell you, oh, I already changed. They change silently, didn't tell you. So delta y here is actually is a small change for y. Delta x is a small change for x. It is give you a notes for you lah. Okay. So to finding either is delta y or delta x, small change for x, small change of y, please solve the dy dx first. Given a 1 value, just find the dy dx and okay, find either is to find delta x or delta y first. If got x, find delta x. Okay, Sometimes got good two number given you, and you need to find delta x or delta y. And then the third step, okay, by doing this step, and then I either finding delta y or delta x or other things. Okay, later on we can find for delta x or delta y. So this is for finding the small changes. Let's see one question very clearly about this one. Okay, y equals to 4x cubed minus 3x squared when x increase from 1 to 1.05. Okay, increase. So here is x. So I can say that delta x is 1.05 minus 1. So it's 0.05. And I do the differentiation first for this one. Later on, I already got differentiation. I already got the delta x. And I sub the x inside here. I sub the x inside here. I will get delta y over delta x is this answer. What the question asks? To find the delta y. Okay, delta y approximately to dy over dx times with delta x. Okay, do the same thing until the answer is this one. Okay, going to right unit also no problem. Actually, it's acceptable. Okay, it's quite easy. But for this, how you do? The area of a drop of oil which is spread out in a circle increased from 4 pi cm squared to 4.05 pi cm squared. That is area. So we can say that is called A. So A equals to 4 pi. 4.01 is increased. So delta A equals to 4.01 minus 4, you get 0.1. 0.01. Okay. Find the corresponding small change in the radius of the oil. So what you want to find? I want to find what? dr, the radius, the small change, the delta r. So what you do? Okay, because you know that oil, okay, is circle. Circle means the area of the circle is A equals to pi r squared. You do the differentiation. Okay, you get the dA over dr is 2 pi r. Okay, and then you're finding the area with node is 4 pi. And then later on, what you do, because A equals to pi r squared, so automatically you sub inside here. Okay, then you cancel out the pi, and what you get, r squared equals to 4. Okay, and then r equals to 2. Remember, radius cannot be a negative. So we use the positive value that is larger than 0. When r equals to 2, you can find for dA over dr is 4 pi. Because this time I said I already got delta A, so I just do like this to find delta r. Sub the value inside, then you get the answer delta r equals to 0.0025 cm. Okay. Kalau untuk versi bahasa Melayu, saya rasa kamu boleh faham lah, sebab saya pun ada bagi dalam bahasa Melayu juga nota ini. Okay. Kita akan tengok terhadap soalan-soalan trial. Okay, dulu. Okay, dalam soalan trial, okay, akan bagi question yang macam ni. Okay, proving question is very popular for this chapter, and also for the small changes, the rate of change, finding the turning point, all that. That is very popular. Okay, usually you find differentiate only 2 marks, but for the proving, it's very large marks. Sometimes got 3 marks, 4 marks. Okay, but usually 3 marks lah. Okay, sometimes got question like this one. This linguism learn. It's quite difficult. Okay, but if you know about this thing, we call this one. This is the reciprocal. Okay, so need to find the point that is undefined, means undefined. Okay. Okay. For further explanation about this chapter, okay, you can join my tuition, one-to-one tuition. Okay, you can WhatsApp my phone number. Okay, for sure you can. And you can ask for anything about this chapter, also can. Okay, for more information about my one-to-one tuition, please contact my WhatsApp number for more information. Okay. So, in a conclusion, differentiation, you need to know about the idea of the limits. Okay, and you know about differentiation formula. Okay, about quotient rule, change rule, product rule, all that, and also the rules that you know just now we learned in part 1. And now we already touch for the application. Tangent and normal, you can use the differentiation in rate of change. You know about the stationary points, all the points. We also call as a turning point. Also, you can use for small changes and approximations. That's all is for the Form 5 Chapter 2 differentiation. Okay, our next class is Form 5 Chapter 3 integration. It's also quite long chapter and it's more harder than differentiation because there is more things you need to know about it. So that's all from today. Okay, we will see in the next class. Thank you for watching and goodbye.